Let's try this out. Yeah, that looks really cool. Hi everyone, welcome to this episode of Think, Learn, Do. For this episode, I got my circuit board for my color changing flashlight. I did a prototype a while back. So we're going to be taking this and populating all the parts on here and hopefully turning this into like a cool little self-contained color changing flashlight. I'm not going to go over the schematic on this. I'm going to put that up on GitHub, and I'll put a link in the comments so you guys can check this out, along with all the bill of materials and all the files that I used for this. But basically, up here on the front we have our RGB LEDs, the WS2812B. Then we're going to have here is where we're going to put our potentiometer to change the colors. The power is going to be here. Our microcontroller is going to be here. It's just an atmega 168P, I think. It's a pretty simple layout. Then we've got our power voltage regulator here. One of the first things I noticed when I got this out and was getting it set up is I screwed up my my footprint for these LEDs. So that's definitely going to be in the next revision. Make that actually so you can put those in without having to mangle the legs. So that's going to be fun to see if I can make that work. And then another thing we're going to show is, I want to show on this is taking an Arduino, breaking out the microcontroller, which is what we want. And it's pretty simple to turn that into a standalone project with just the atmega microcontroller, so we don't have that big board lying around. So I wanted to show you how we could do that with this project. So the first thing we're going to do is, I've got this Arduino programmed with the Arduino ISP program. That'll allow us to program these raw atmega chips. Oh, that's my socket. So I've got some raw atmega 168 microcontrollers here. I'm going to hook the chips up on this breadboard, and we'll run some wires out here. That'll allow us to burn the bootloader to this atmega chip, and then we'll be able to use this again to upload our program onto this chip. Okay, so I had some problems getting this working on the breadboard, so I actually ended up taking off this chip and putting it in another Arduino that I had. And we can run power over here, and then we have our serial connections going into these pins. I will have to diagram this up because that page I was going to use isn't going to work for this setup. And then we have a capacitor here to block the reset signal that's going to come from the computer. That may not be necessary. I just have in my notes that I need that, so I'm going to do that. Then our reset, our pin 10 here, it's going to go to our reset on here so we can reset the atmega chip. Okay, let's burn that bootloader. So the bootloader I'm using is actually an 8 megahertz internal clock. So to keep this simple, I didn't want to have an external clock on here. And these atmega chips come with an internal clock that you can use. You just have to set it when you burn the bootloader. I'll put a link in there in the comments as well to point to that bootloader that I'm using. And let's burn that. Gonna watch some lights blink and it should finish. It says it's good, so that's a good sign. So next what we'll do is I think we take this chip out, we'll hook up directly to this, and we're gonna actually put the chip back in our breadboard at this point. And then by using the empty Arduino board, we can program this chip over the serial connection. I've got my serial connection hooked up here and reset to that pin there, and it's got power. Let's see if we can make this work. Alright, I said it worked, so hopefully our chip program now. Let's build up our board, and it should just work. Alright, next let's do our power. So we'll put in our voltage regulator, our output capacitor, and our input capacitor. Alright, real quick. So here's my input capacitor. Since it's a ceramic capacitor, well, at least with this one, it doesn't matter the polarity on this one, so we can put it in any way we want. And then with this one, because it's polarized, or it has a positive and a negative side, we need to make sure we put it in the right way, or else it'll explode when you power it up. So looking at my board, you can see there's a little positive sign here. There's also this white on this leg. So the white corresponds to this, you can see this negative mark. And it's the black stripe. And there's also a little negative in there. Come on. Yeah, there it is. Come on. Right there. So that negative leg needs to go through this white hole, and the longer leg, which is also positive, needs to go through this one that's not covered in white. Next up, we'll put in our 9-volt battery holder, and then for a quick sanity check, we'll plug things in and make sure I can get some power out of my voltage regulator. Looking at our schematic, it looks like I can hit this pin here with my multimeter, and then it should be a positive, and then I'll just probably try and plug into like the negative here to measure our voltage, make sure we're getting 5 volts. So yeah, I double checked my data sheet. And it does look like I did that backwards. So this is input, ground, output. And I definitely hooked it up backwards. So this last one's supposed to be input. So yeah, I'll have to fix that. Okay, that was a huge pain. I got switched around the right way. I just test this, that this does work now. We'll just show it here real fast. So I've got ground here, and then power here. Yeah, I'm gonna those are 5 volts like I expect. So just a reminder to double check your pinouts, but it's working now, so let's keep going. Okay, so we've got our power figured out. So next up, we can put in these next 2 resistors. One of these is our pull-up, and what that's going to do is on the atmega, there's a pin here that we have to give positive voltage for it to turn on the microchip. And then, so what we're going to do is we're going to have a pull-up resistor. Basically, all this is doing is saying, it's going to be hooked into our positive voltage, and it's just going to apply positive voltage to this pin. And the resistor is there just to make sure that we don't pull too much amperage and either damage it or drain our battery really fast. And then this other resistor is a smoothing resistor, or it's going to filter out our data line for these 3 LEDs, and it'll just help smooth out the signal and make it hopefully be good. It may not be necessary for such a small project, but we'll have it there in case we need it. Alright, so I've got my two resistors in. Next up is I'm going to put in my LEDs. So after double checking my data sheet again, it looks like these two short ends, this is my data in and my voltage in, ground and data out. So looking at my circuit board, it's going to look something like that. So my short leads are going to be on this side towards the atmega. Okay, LEDs are in. So next I'm probably going to put in these little capacitors here. I don't know if you can see where those are. But these are just, according to the spec, it needs, or according to these data sheet on these LEDs, it needs just a 0.1 microfarad capacitor between the power and ground, so we're going to put those in. Alright, capacitors are in, so last thing is our potentiometer, so we'll put that on. Okay, it should be all assembled. There is a LED I can put in here, but I don't really need that. But we can test this out and see if it works. You can see here, there's a dip here. It's going to match up with the dip silk screen on our board. And the dip that's on our holder. Alright, I just spent a lot of time troubleshooting a fun problem. What I learned was this chip that I'm using is an atmega 168A chip. The bootloader I programmed on here was for the atmega 168PA. So apparently there's enough of a difference there that it wouldn't actually start up. So once I pulled it out of here and redid my bootloader programming with the 168A, that solved that problem so that it was actually loading my program. The next problem I had was on my program, I actually had the wrong pin for controlling these the data line on these LEDs. So I've also fixed that problem. And then I did eventually put my indicator LED in here so that I can see when it turns on, because that's really useful for knowing that my program's running. So this is what it actually should look like when it actually works. There's my LED turning on. Okay, and then these are just still crazy bright, which I love because I wanted this to be like a flashlight thing. You can see that I'm turning the potentiometer here. That sticks out kind of, hopefully far enough that you can reach that with your fingers and still get the light shining on there. So to finish this up, what I want to do is make it so that I feel a little more comfortable letting my kids hold on to this without getting electrocuted or shocked by any of these pins on the back. So, and then I also want to try and bend these forward so it's kind of like a flashlight. You hold like this and it's shining that way actually. So I'm going to carefully bend these pins, or bend my LEDs so they're kind of facing that way. And then another thing I wanted to do was put this like clear heat shrink on here. I actually sell this huge heat shrink tubes, so that's pretty cool. We'll put this on here and then cut a hole so that this kind of protrudes through it, and then we can hopefully still be able to manipulate this. And I'll let my kids try it out and see what they think. Well, that didn't quite work. It just kind of tore right there. I'm gonna have to do something a little different, I think. Luckily I got lots of heat shrink to play with. See if we manage to make sure this still works after I heat shrinked it. I mean, the back worked out really well. Front though, that definitely needs a different way to do that. Of course, getting it back in now is going to be a pain. It still turns on. That's a good sign. Let's try this out. Yeah, that looks really cool. So other than that tear right there, I kind of like how that came together. I'll have to come up with a better solution there. I'm guessing maybe like a hole punch or something. Fun. So, a couple of lessons learned. Double check my pinouts before I put stuff on. That was hilarious. And then I'm going to have to redo this board and get a smaller so they can fit in a little bit better on these LEDs up in the front. But yeah, at least I got it to work, and it works like I want. And I also need to come up with a better way to make the hole there. But yeah, that was a lot of fun. And thanks for watching.